Okay, hi everyone. Sorry for the delay. I just came out from another class. Just wondering if you can hear this sound. Please indicate in the live chat. Thanks for telling me your uh, attendance. Okay, please indicate in the live chat if you can hear me. And if you can, then I will start. Lah. Is the sound okay? Can you hear me? Testing. Okay. All right. So today we're going to continue on our study in chapter 4, okay, on the study of electronics. And we're going to uh, actually continue talking about semiconductors and another use of semiconductors. Uh, so the first one that we saw, okay, one of the uses of semiconductor is to form a diode. Okay, and a diode is formed when you form, when you join together two types of semiconductors, which is the p-type and the n-type semiconductor. So when the p-type and the n-type semiconductor combine, okay, what you get, okay, is a diode. So that's one of the uses of using a semiconductor. Okay, now another use, which is what we're going to look at today, is to look at transistors. Okay, transistors is another electrical component that is very important in any electronics device. Okay, pretty much like the diodes lah. Okay, diodes are also important. Transistor is also another important. But the difference between the transistor and the diode is, kalau diode kan, dia hanya dua saja. Okay, diode is, let me see. Okay, for the diode, let me see. Okay, for the diode, it's just one one N-type semiconductor and one P-type semiconductor. Okay, and the symbol for diode is one triangle, one palang, and then like this lah. Okay, so the function of the diode is to allow current to flow through one direction only. Okay, and there are two ways of connecting the diodes. Okay, which is forward bias. Okay, where the p-type part of the semiconductor is connected to the positive of the battery, and the n-type is connected to the negative of the battery. The other way to connect is reverse bias, okay, where the p-type is connected to the negative part of the battery, and the n-type, okay, the n-type is connected to the positive part of the battery. Now, the forward and reverse bias basically serves the same function. Okay, forward bias is to make sure that the depletion layer here is narrow. Okay, because in its natural state, kalau kau tidak letak apa-apa voltage over here, okay, there is always going to be a depletion junction. Sorry, a depletion layer lah over here. Okay, sebab naturally lah. Okay, so we do forward bias to make the depletion layer narrow, and we do reverse bias to make the depletion layer wider. Now, if the depletion layer is wide, okay, then there's not enough energy for the electrons to cross over to fill in the holes. Okay, but so the function of the voltage is to make sure that the depletion layer is narrow enough so that the electrons can cross over. Okay, that's the main thing that we need to understand from this one. Because when we talk about transistor, when we talk about transistor, okay, it is now a combination of three semiconductors, okay, which is the NPN transistor. So there are two types now. One is the NPN transistor, and the other one is the PNP transistor. Okay, this P and N just talks about the P type and the N type lah. Okay, but the main form of transistor that we want to talk about now is the NPN transistor. Ini a little bit famous lah. Okay, especially for us. Now this is the symbol for the transistor. The transistor consists of three legs. Okay, 1, 2, 3, as you can see over here. Okay, 1, 2, 3, as you can see over there, and the three legs got different this one. So the C, B, and E lah. Okay, no matter whether it is an NPN transistor where the arrow is going towards the E, or the PNP transistor where the arrow is going from the E. Okay, now the C leg is called the collector leg. Collector leg lah, collector lah. Okay, B is for base. Okay, and E is for emitter. Okay, dalam bahasa Melayu, this is pengumpul, this is tapak, and this is pemancar. Collector, oh dear, my handwriting. Collect lah, collect as in mengumpul lah. Okay, pengumpul, tapak, and pemancar. Collector, base, and emitter. Okay, so this is the first thing that you need to know. Okay, the second thing you need to know is that when current flows through, I'm going to use these words a lot. If the current flows through the collector, we call this the collector current, which is IC. The current that flows through the base is called the base current. Okay, and the current that flows through the emitter is called the emitter current. Okay, which is IE, IC, and IB. Okay, now this point number 9 over here is probably the most important of this very long thing lah. Okay, now the base current, okay, is used to control the collector current through the transistor. Okay, so the base current actually determines whether this transistor is, we call it switch on or switch off. If there is a base current, if there's enough base current, then the transistor will turn on and then the collector current can flow. I repeat, if there is enough base current, then the collector current can flow and if there is enough base current, then the transistor can switch on and then the collector current can flow. Okay, which means the collector current is very dependent on the base current. Kalau tiada base current atau kalau base current is not enough, then the collector current cannot flow. Okay, now the reason why this happens, the reason why this happens is something to do with this one, the forward and reverse bias. Okay, so I want you to consider this very normal setup. Okay, very normal setup for NPN transistor. Okay, I only want to consider NPN transistor lah. Okay, because that's our main focus in this subtopic. Okay, this is a circuit that everyone has to remember. Kalau ini R2 dan R1 kamu tiada pun tidak apa. Tetapi yang paling penting is this. If we consider the transistor like this, okay, and we know that this is N, in the center is P, and over here is N. Okay, now take a look at, I'm going to change this to green color. Okay, take a look at this N and P junction and this junction. Okay, you will notice that this is connected reverse bias. And because the N is connected to the positive and the P is connected to the negative. Okay, saya mau kamu consider these two first. Don't look at these two yet. Okay, this is reverse bias to this, which is a very big problem because if it is reverse bias, means if let's say I draw the junctions over here, okay, means this depletion layer is very big because they're reverse bias lah. Di sini ada depletion layer. That's why in its normal state no current can flow here because it's reverse bias. Okay, now let's consider this circuit pula. Okay, this leg is connected to the P junction, this is connected to the N, and we find that in this section, okay, going to change this to blue color. Okay, in this section, this is what kind of bias? This is forward bias. Okay, that's why it must be set up like this. Okay, so if this is forward bias, means current is flowing over here. Okay, and as I said just now, the transistor can only switch on if the current is big enough, if there's enough current so that, okay, so that this depletion layer becomes smaller and this depletion layer also becomes smaller. Okay, take a look. If this depletion layer becomes smaller, this one also becomes smaller. When this depletion layer is small enough, okay, then current can flow, walaupun dia reverse bias. So that's the function of this voltage over here. This voltage over here, the function is to make sure that, okay, this depletion layer become small enough so that current can flow. And that's what makes transistors are very amazing. Transistors can function as automatic switches. Okay, because this one can basically be switched on and switched off bergantung kepada how much current is flowing over here. Okay, I'm going to read this. Base current is too small compared to collector current. Okay, the unit of base current is usually microampere, and the unit for collector current is usually milliampere. Okay, usually it's about 1,000 times difference lah. Okay, but the most important thing is this lah. Okay, is that when collector current flows over here, this current over here plus the collector current is equals to the emitting current, the emitter current. Okay, IE equals to IB plus IC. The only formula in this chapter, in this subtopic. Okay, so that's the thing you need to remember lah. This one can only be switched on if this depletion layer is small enough. And how do you make sure that this depletion layer is small enough? You must have enough voltage over here to make sure that, okay, this depletion layer is small enough. Because kalau kita tidak bekalkan apa-apa tenaga di sini, okay, kalau ini je yang ada, okay, this is very big depletion layer because this is reverse bias to this. So current cannot flow over here because its depletion layer is very big. Okay? Walaupun di sini adalah forward bias, but the problem is current flows through here. Kan? Sampai di sini depletion layer terlalu besar, cannot go over. Okay, so we need to make sure that this depletion layer becomes smaller. And how do we do that? Is we supply the base current, okay, or the voltage lah. Okay, there must be enough voltage to make sure that this depletion layer becomes smaller. Okay, right. So there are two functions to the transistor. Okay, two main functions to the transistor lah. The transistor can, of course, work as an automatic switch. Okay, the first one I want to talk about is automatic switch lah. Okay, and basically it is if there is no current flow in the base circuit, then there is no current flow in the collector circuit. Ini je kau perlu ingat. No current here means no current here. If there's enough current here, the transistor will be able to switch on because this depletion layer sudah menjadi kurang and current can flow over here. Okay, it's a very important thing. Now, the second one is the transistor can also function as a current amplifier. Okay, as we said just now, the current over here is very small and current over here is very big. Okay, usually hundreds to 1,000 times more. Okay, so all you need is just a little bit of current here, and then here, you know, the current can flow much, much bigger. And we will look at this current amplifier in a little while. How does the transistor amplify the current? Okay. Alright, so dari segi fungsi okay, this subtopic actually a lot of people find it tough because there's a lot of explanations lah. Okay, but actually the more important thing in this subtopic, especially if you're heading towards exam, is the function of the transistor. I think if you can explain the function of the transistor in the circuit, okay, you are actually good enough lah. Okay, boleh sudah kamu jawab soalan berdasarkan ini. Yang saya cakap sebentar tadi tu kan is the explanation lah. Because a lot of people be like, how come it's reversed by, how come this one, that? Some people want to know that. Okay, but some people don't. Some people just want to know, you know, how does the circuit function lah. Okay, so let's talk about the transistor as an automatic switch. Okay, now over here, we have another setup. Okay, but notice that this time, berbanding dengan ini there is no battery supplied over here. Okay, on the base circuit, there is no battery supplied. All you have is just a varying resistor. Okay, a varying resistor atau what is it called? Okay, rintangan yang boleh berubah lah. Okay, so what happens over here is this 6 volts is supplied here and also supplied here at the same time. Okay, but because there is two different resistors, okay, the thing you need to remember is the bigger the resistor, the bigger the voltage. Okay, siapa yang mempunyai resistance yang lebih besar, dia akan memerlukan lebih banyak voltage. So this 6 volts will not be divided equally if this is not, kalau ini 10, ini 10, then okay lah, this will be 3 volts, this will be 3 volts. Okay, but if I increase this resistance to more than 10 kilovolts, then sini akan menjadi maybe 4, sini akan jadi 2. Okay, so what happens is that if this voltage is big enough, okay, let me repeat, if the voltage is big enough, then the base current can flow. And if the base current reaches a certain minimum value, okay, then what will happen is this transistor will switch on and the collector current can flow. Okay, so point number 4 and number 5 is the most important. When the base voltage, okay, or the base current reaches a certain minimum value, okay, the base current will switch the transistor on and the collector current can flow. And this makes this menthol light up. Okay, but the condition is this, syaratnya adalah ini. Okay, the resistance here must be bigger than the resistance here. So that, okay, so that the voltage here will be bigger than the voltage here. Okay, enough voltage here, as long as it's bigger, okay, then there's enough current. Okay, so that's the function of these two resistors. Okay, we call this one, we call this circuit we call this a voltage divider circuit. Voltage divider. Okay, something is wrong with my handwriting today. Okay, we call this a voltage divider circuit because basically it serves to divide the voltage. Okay, so the important thing again, let me repeat because balik-balik saya repeat kan, it means it's very important lah. Okay, you must have a big enough voltage down here so that, okay, you can turn on the transistor and make the collector current flow. Okay, because, okay, yang menyebabkan the transistor switch on is the base current, correct? Okay, but if you want to put it very simply, very easy. Voltage big enough, transistor switch on, collector current can flow. The moment collector current can flow, then whatever yang kita pasang di sini, in this case is a menthol, it will light up. Okay, and that's what we want. Okay, itu yang kita mau. Selagi this voltage is not big enough, if the voltage is not big enough, then this transistor will be switched off. Transistor switch off means collector current cannot flow. Collector current cannot flow means the menthol will be useless, just staying down there doing nothing. Okay, and because of this potential divider circuit, okay, we can use it in two main things lah. Okay, if the variable resistor in the transistor is replaced by a device such as the light dependent resistor, a thermistor, or a microphone, okay, the transistor can be used as an automatic switch controlled by light, heat, or sound. Okay, let's take a look at the first one. The first one is a light control switch. Now, a light control switch is very normal. We will always see this, contohnya di lampu jalan lah. Okay, for example, lampu jalan bahkan nobody goes to the lampu jalan and turn on the light at exactly 6 p.m. every evening. Nobody does that. But you notice that it will automatically turn on by itself. Okay, why? Because of this switch, which is called a light control switch lah. When there is enough light, okay, depending on the situation you want, saya mau cakap di sebelah kanan dahulu lah. Okay, now the circuit switches on the bulb at night and switches off the bulb at daytime automatically. Okay, means bila dia cukup cahaya, okay, then it will turn off the light bulb. Bila dia terlalu sikit cahaya, okay, if it is too dark, okay, then the light bulb will turn on, okay, by itself. And all this has to do with the transistor and this very important component which is called an LDR. LDR is called a light dependent resistor. Okay, light dependent resistor, perintang peka cahaya. Okay, dia sangat peka kepada cahaya. And this is the important thing. Okay, the LDR has a very high resistance in darkness and low resistance in light. Okay, because after this we're going to see a heat control switch. So I want you to make sure that this difference. LDR is in darkness is high resistance. Low in bila dia terang, okay, they have very low resistance. Okay, so think about this. If we put the LDR over here, okay, pada sebelah siang, Okay, sebelah siang, remember there's a lot of light. A lot of light means less resistance. Kalau less resistance means low voltage. Kalau sini low voltage, sini akan menjadi, kalau sini low voltage, sini akan menjadi high voltage. So if the high voltage is up here, no use. Because we want the high voltage to be here. Kalau kita mau switch on the transistor. So because over here has low voltage, the transistor will be switched off and the bulb will not light up lah, because there's no collector current. Okay. Now sebaliknya, at night, okay, at night tidak cukup cahaya. So here will be high resistance. High resistance means voltage will be lower. Here will be voltage. Sorry. Resistance here will be higher than here. Ini 5 kilo ohm ni kan memang kekal. Tapi ini because of the low light, okay, dia punya resistance akan menjadi lebih tinggi daripada 5 kilo ohms. So because of that, over here will have more voltage, over here will have less voltage. Voltage is enough to turn on the transistor, and because of that, collector current will flow and the light bulb will light up. Okay. So notice the pattern. Notice the pattern. Kamu kena tahu situasi di mana resistance-nya cukup tinggi. Bila resistance-nya cukup tinggi, the voltage on the base circuit, okay, will be high. If the voltage on the base circuit is high, then the transistor will switch on and then the collector current will flow and the light bulb will light up. Okay, the order is always like this now. Your task, okay, tugas kamu adalah untuk mengingati dia punya urutan. Okay, remember the condition where we need the resistance to be high or low. Okay, resistance high or low, voltage high enough, current will flow and switch on the transistor, collector current will flow, bulb will light up. It's always that order. Okay, tinggal kau kena ingat lagi lah. Okay. Now, this is a ridiculous situation lah, but sometimes people will do it anyway lah. If we put the LDR up here, okay, think about it. Okay, sebelah siang. Sebelah siang, LDR, low resistance. Low resistance means low voltage, means over here voltage yang lebih tinggi. So, bulb will switch on. Kan? Because sini voltage tinggi, transistor will switch on, collector current will flow. So, sini akan pasang. Which is pretty dumb lah, kan? Who will want to turn on the light at the daytime? Tapi ada juga orang begitu. Okay. Now, how about at night time? Night time, resistance over here is high. Sebab this syarat very important. High resistance in darkness. Okay. Resistance over here is high. Voltage over here is higher than this. So over here, because the voltage is so low, okay, transistor will be off. Transistor off means no collector current. So the light bulb remains dark. Right, remains dark. The light bulb just won't switch on. Okay, the light bulb will be switched off at night. Okay, so remember, high resistance at night, okay, and low resistance in the daytime. Sangat-sangat penting. So, where you put the LDR is very important. Don't sembarangan letak saja tau. Okay, it depends on the situation that you want. Okay, I repeat, it depends on the situation that you want. I say this because both of these questions have come up before. Okay, it doesn't make sense. Kenapa kita mau pasang lampu pada waktu siang? But, well, there you go. Sometimes the question asks like that. So you need to know. If it is at night, the LDR is down there. If it is at daytime, okay, the LDR is up there. Very important. Okay, because of this condition. Okay, LDR kalau sebelah malam dia high resistance. Kalau sebelah siang dia low resistance. Okay, just if you have any questions you can ask. Okay, I'll try to answer in a while. Okay, right. So another type of control switch is a heat control switch. Okay, now heat control switch is kalau it's the same circuit. Okay, it's the same circuit as just now. Okay, you have a transistor and you have two resistors. This resistor I will talk about later. Okay, and you have of course the battery which is sambung to the alarm lah. Now the heat control switch is to mengesan haba. Okay, and this is usually where we have for example smoke detector lah. Okay, smoke detector or fire alarm. Okay, if it is hot enough, okay, if it is hot enough, then the alarm will switch on. This is what we want. Kita mau bila keadaan terlalu panas, then the alarm will turn on. Because, you know, that's what the fire is for lah. Okay, so this is a very important thing. So instead of the LDR just now is light dependent resistor. For heat control switch, we use a thermistor. Okay, thermistor because dia adalah resistor yang bergantung kepada thermo. Okay, which is the thermometer lah. Okay, so dia adalah resistance becomes very high when it is cold. Okay, I repeat kalau cold, okay, resistance is high. Kalau hot, resistance is low. Okay, very important. So how does it function? How do we want to turn on the alarm? We want to turn on the alarm bila transistor switch on. Kan? But transistor can only switch on kalau resistance di sini adalah lebih tinggi daripada sini. Here must have high resistance in order to have high voltage. Here must have low resistance. Okay, so when it is very hot, okay, bila dia menjadi panas, the thermistor will detect the heat. Dia akan mengesan itu haba, okay, and it will reduce the resistance. So because here the resistance is reduced, therefore the voltage yang melalui sini pun akan reduce. Di sini akan menjadi voltage lebih tinggi. Voltage lebih tinggi di sini, transistor switch on, collector current flow, alarm begitu. Okay, when it is very hot. Dalam situasi biasa, okay, in very room temperature lah, for example lah, okay, in room temperature, the resistance over here is high. Okay, because thermistor dia punya function memang begini. Its resistance becomes very high when it is very cold. Okay, so because of the resistance high, the voltage will always be higher than here. Here will be low voltage. Sini low voltage, transistor switch off, alarm, no sound. Okay, so all this explanation yada 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 yada. So, but this is the important thing lah. Kalau if there's a important thing that you need to remember, okay, it is point number 2 and point number 3. Okay, resistance becomes very high when it is very cold. When it is cold, okay, and when the thermistor is heated, the resistance drops rapidly. Oh dear. Okay, so resistance drops, sini resistance high, voltage high, transistor on, collector current flow, alarm will berbunyi, and that's what we want. Okay, so which is why we put the thermistor up here. Kalau kita letak thermistor over here kan, then your alarm will forever be ringing, and then bila ada api the alarm will turn off, which is kind of bodoh, right? So that's why. So this circuit we use in a fire alarm system. Okay, the function of the diode in this circuit is to protect the transistor from being damaged. Okay, it's just you just need to know this lah. Okay, but the way to explain the light control switch, okay, and the heat control switch is the same. All you need is just di bawah mesti cukup voltan. Kalau cukup voltan, transistor will switch on, collector current will flow. Okay, I mean, sorry, when the voltage down here is bigger than the voltage on the upper resistor, okay, then you have transistor switch on, collector current flow. Always the same. Cuma, dia punya condition for the resistor is different. Kalau LDR, light dependent, at night is high resistance, at daytime is low resistance. Kalau heat control, when it is cold, it's high resistance. Okay, when it is hot, it is low resistance. When it is hot, it is low resistance. Yeah. Okay, so if I want to summarize it now, oh dear, sorry. Okay, if you want it, if you want a simpler way to remember lah, well, it's not that simple lah, but can lah. Okay, so low, kenapa ni? Sorry Okay, so low resistance. Okay, low resistance is when it is hot and when it is daytime. Okay, high resistance, okay, is when it is cold and when it is nighttime. Okay, when it is cold and when it is nighttime. So thermistor we put up here. Okay, because kita mahu supaya when it is low resistance, when it is hot, it will be low resistance. But LDR, okay, LDR, we put it down here. For normal situations, remember, for normal situations, kita mahu mental hidup pada waktu malam dan turn off pada waktu siang. So LDR we put down here. Tetapi thermistor kita letak atas sini. Okay, but it is better to remember this situation lah. Okay, then you know where to put the thermistor because the resistor dia punya kawan satu lagi tu is just a normal resistor. Okay, so you are required now. Okay, ini memang saya mau lah. Okay, you are required to memorize the circuit. I want you to memorize the circuit. Okay, whether it is as simple as this or the one that is in your reference book lah. Okay, you need to draw out the circuit and draw it out again and again and again and again. Okay, so that you remember how the circuit. Of course, you need to know how to explain it as well lah. Okay, but I guess when we go back to school then we will talk about it. Maybe I'll do a test on this lah. Okay, like our usual 4-mark test. Okay, right. Another one is how does a transistor function as a current amplifier? So there are two functions of transistor, remember. Number one is an automatic switch. Okay, it can be switched on, it can be switched off. Now another function is a current amplifier. Dia membesarkan arus. Okay, which is actually one of the main functions of a transistor. Okay, so a transistor functions as a current amplifier by allowing a small current to control a larger current. Okay, the magnitude of the collector current, okay, is determined by the base current. A small change in the base current will cause a greater change in the collector current. Okay, this is a very important thing. Point number 3 yang sangat penting. Okay, kamu ubah this one a little bit, you change it by changing the resistor lah. Kamu membesarkan the resistor, you will change the base current. You change the base current, okay, you will cause a greater change in the collector current. Okay, and one of the main users of transistor as a current amplifier is seen in our sound amplifiers. Okay, kalau kamu buka amplifier, if you have an amplifier at your home or in church or wherever, if you open the amplifier, you'll see lots and lots and lots and lots of transistors over there. Okay, especially the old amplifiers nowadays everything is electronic so a little bit everything is digitalized so it may be a little bit different, but the basic function of the transistor is still there. You see lots and lots of transistors because amplifier dia punya function is to amplify the sound. You talk into the mic amplifies the sound and then keluar di loudspeaker. Okay, so how is that done? It is by using the transistor. Nobody shouts into the mic kan, then dia punya suara adalah sama kuat dengan speaker, which doesn't make sense. Why would you need a speaker kan if you can speak as loud as the speaker? Okay, so that's why it's called sound amplifier, pembesar suara. Okay, dia membesarkan suara dengan membesarkan arus. It amplifies the sound by amplifying the current. Okay, and how is this done? So the microphone converts the audio sound. Bila kamu okay, for example this one lah. Okay, blah blah blah. It converts it to electrical signal. Okay, with changing currents because your voice is different. Okay, or different loudness. Ha hu. Okay, so it converts the audio sound into electrical signal. Okay, the capacitor allows the varying current to flow through it and prevent direct current to flow from the battery to the transistor, okay, and the microphone. Now, when you speak, okay, and then the microphone dia punya tugas adalah mengubah isyarat bunyi kepada isyarat elektrik. Okay, isyarat elektrik mengalir melalui sini. Okay, then you find that the base current is changed. Okay, and because the base current here is always changing, the collector current is also always changing. Okay, and remember the transistor functions, macam saya cakap tadi when you change the collector current when you change the base current, okay, a little bit okay, the change in the collector current adalah jauh lebih banyak. Kamu ubah sikit di sini, terus di sini mengubah banyak. Okay, and that's the special thing about transistor. That's what the transistor does. Okay, the base current is changed and causes a large change in the collector current. Walaupun kamu bercakap macam tu kan, yang sangat soft kan, tetapi the electrical signals are always changing. Okay, the the value of the current, the base current is always changing. So because of that, okay, bila collector current flow kan dia akan menjadi lebih besar. Okay, so collector current flows in a loudspeaker and the sound waves with higher amplitude is produced. Okay, and that's how a sound amplifier works. Changing base current menyebabkan bigger change in collector current because of the transistor. Okay, the transistor amplifies things a lot. Okay, so that's how the sound amplifier works. Okay, and that's basically it. Okay, that's basically it for this subtopic transistor. It's a very small subtopic, okay, but this is one of the subtopics kan yang sikit betul pengiraan, tetapi banyak betul yang kamu kena ingat, yang kamu kena faham. Okay, so what I want you to do is I'm going to send a series of objective questions. Okay, this whole week I want to focus on this subtopic and also the semiconductor diodes now. But for today's class, I'm going to send you all a series of objective questions. Part of the objective questions is for your revision, for your trials. So memang daripada subtopic pertama ada, okay, and part of it is also for this subtopic lah. Okay, that's the first thing I want you to do. The second thing I want you to do is I want you to draw out. I want you to draw out the light control switch and the heat control switch circuit. Okay, you can take a screenshot of this later when I put up the video, okay, on YouTube. You can take a screenshot of this one, or you can just refer to the reference book, okay, and draw out the circuit. Okay, once you draw out the circuit, then obviously I need you to memorize the circuit. Today, I just want you to memorize the circuit first. Then we will go and talk about explanation, memorizing the explanation lah. Okay, don't worry, I won't ask you to do flip video lah, but okay, but it's important for you to remember this because this topic hasn't come out in quite some time, and you know, who knows, mana tahu dia akan keluar lah. Okay. All right, let me see if there's any questions from anybody. All right, no questions from anybody. So there's a little bit more time. So I'm going to send the objective questions into the group. Okay, and then I want you to finish it and then send it to me personally. Okay, PM me your answers, and then I will check for you. All right, that's all for today. I will see you in the next class.